So in this related rates problem, we read that sawdust is blown out into a conical pile such that its radius is always half the height. And I think we're going to need that in a little bit. If the sawdust adds 3 pi cubic feet to the pile per minute, okay, 3 pi cubic feet, how fast is the height of the pile changing 15 minutes after it starts? Okay, so here we go. Here's our conical pile of sawdust here. So let's take a look at what do we know? Okay, first of all, it's going into a conical pile and its radius, okay, the radius of the pile and the height of the pile, we always know, okay, that the radius is half the height. Okay, we're told that right off the bat here. Radius is always half the height here. So I'll throw that up here. Well, I'll leave that down there. We can see it right there. We know that the sawdust is adding, actually I'll zoom in a little bit here. We know that the sawdust is adding 3 pi cubic feet to the pile per minute. So that's a change in volume with respect to time. 3 pi cubic, that's feet cubed per minute. That gives us some units and whatnot. What we're asking here is what we want. Okay, what we want here is how fast the height of the pile is changing, dH by dt. Well, okay, we know that the formula for the volume of that cone is going to be 1/3 pi r squared h. Okay, now this isn't an ideal equation here because we're given the rate of change of the volume. We're asked for the rate of change of the height, but our formula also has radius, and as this pile gets bigger, the radius is going to increase as well. So we have to do something about that. We also know that we're looking at it, how fast is the height of the pile changing 15 minutes after it starts. So we're actually given a time here, 15 minutes. Now, notice that time doesn't really play a factor in our equation here. We're going to have to figure out where that fits in just a moment here. First of all, though, what we're going to do here is we're going to start with our volume equation. Okay, 1/3 pi r squared h. Now the thing is, I want this in terms of just volume and height because those are the two variables that are changing that I'm interested in. I know the one, I'm looking for the other here. So I got to get rid of r. Fortunately though, if I look back up to the information that I've got, I know that r is equal to height over 2. So I can make that substitution right now. This will become h over 2 squared times height. Put that all together and we're going to get pi times h cubed over 12, and there's my volume. So volume is now expressed in terms of just height here. Great. Now let's take the derivative. Okay, so we have to take the derivative with respect to time. We have to do it implicitly because time doesn't factor in here. So bring down the 3. This will be pi 3h squared over 12. And then again, I'm taking the derivative implicitly with respect to time. And so there we go. Perfect. So now we're going to plug in the things that we know. Okay, we're going to look for dH by dt. But I'm going to plug in the things that I know here. First of all, I know that this is increasing by 3 pi cubic feet per minute. Pi, that's easy. That 3 and the 12 will cancel, give me a 4 there. And now I got to know the height. Okay, I don't know the height. That's what that 15 minutes was all about. Okay, that's what the 15 minutes was all about here. So what I know is that we are increasing volume here. Okay, basically think about it like this. Volume is going to equal 3 pi cubic feet per minute times time in terms of number of minutes. Like that's how much is there. So we've got 3 pi, we've got 15 minutes. So the volume at that particular instant of time here is going to be 45 pi cubic feet. Okay, good. So there's our volume at that instant here. Now what I got to do is I got to convert that into a height. Okay, so now I know volume is equal to, and actually I'm going to steal that formula over here because this formula is in terms of just volume and height. That's going to be more useful to me than going back up to this one right now and having to work around the r there. So this is going to be pi h cubed over 12. Oops. Make that 45 pi equals pi h cubed over 12. All right, well, can see right now the pi's are going to disappear. I'm going to be left with 45 times 12 here, so when I multiply those together, I'll get 540 is equal to h cubed. Now, I would love it if that had a perfect cube root to it, but it doesn't. Okay, it doesn't here. What's the best I can do here? I suspect I can simplify this a little bit. So h is going to be the cube root of 540. The best I can do, I believe, is making this 3 times the cube root of 20. Okay, and I don't believe there's any way I can break down that 20 there. So feet. Okay, now over here this was feet cubed. So our height is 3 times the cube root of 20 feet. But there it is. That's the height. This is the thing that I needed now over here. So I will make this 3 times the cube root of 20 squared dh by dt. Okay, now, first of all, okay, just a few little bits of simplification here. First of all, the pi's are going to cancel here. I will multiply up by that 4, so this will be 12. And then I'm going to divide through by this, and this will become 9 cube root of 20 squared. This is my dh by dt. Okay? And based on the units that I've created here, this will be feet per minute. Now, I'll get to that in just a second, because there's a little bit of simplification that we can do here. First of all, the 12 over the 9, there's going to be a common 3 to both of those. So this will be 4 over 3 cube root of, well, 400. Okay? Now, turns out 400 can actually be simplified a little bit here. So this is dh by dt. We're having all sorts of fun with this one. I can actually simplify the cube root of 400 a little bit. It's not huge, but I can take out a 2 here. So this will be 4 over 3. There's a 2 there. This will be the end up with the cube root of 50 is equal to dh by dt. I don't think I can simplify that any further. What, 50 is going to be 5 times 5 times 2. That's the simplest it's going to get. But I can cancel out the 2's here. So, as simple as I can get it right now, 2 over 3 times the cube root of 50 feet per minute is dh by dt. Okay, now, I know that there might be some people out there that are saying, well, wait a minute, no, you haven't simplified it because you haven't rationalized that. Yeah, it's kind of debatable at this time whether or not rationalizing is super important. And so at this point right now, I'm actually okay to leave it just like that. But what I'll do here is I will get a numeric value for this. Okay, so this is about 0. I'll go maybe to the nearest hundredth right now. It's a new day, why not? So, or 0.18 feet per minute dh by dt. Ooh, a lot going on there. There you go.